Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to my channel, and we're going to of course have a discussion of electromotive force in our discussion for today. And this is going to complement on the first videos which we have done, of course, on the concept of charge currents and specific directions in which we are going to expect current to flow. And there were some rules, of course, basic rules which are defined from our first video on a conventional way in which we are going to be identifying the direction in which the current is going to flow, and of course the direction of the electric fields in a conductor. Now in this in a conductor. Now in this specific case, we're going to look at how we can of course evaluate what we refer to as perhaps the electromotive force. And this is going to constitute, of course, other aspects like the current in the circuit, the terminal volts, and some of the power which is going to be realized, and the aspect of internal resistance. And that is going to be achieved through an evaluation or an example, or an evaluation example which I'm going to give in our last bit of this specific discussion. Now, in our previous video, basically mentioned that we're going to require what we refer to as a device that can pump charges into or across these specific components in this circuit. And this specific device is going to be referred to as a source of electromotive force. And of course, in this particular source of electromotive force is going to be having what we refer to as terminals. Now in this case, from this particular symbol, then therefore this is going to be our source of electromotive force, which I've given in terms of that particular symbol. And therefore this is going to constitute of terminals which are going to be in a particular case whereby we're going to use this direct current, then it's going to constitute of a positive and negative terminal in this specific respect. Now we had indicated earlier that we can identify the direction of flow of current in this specific circuit, whereby we're going to see that the charges are going to flow, or the current is going to flow from the positive to the negative terminal, given using these specific arrows. And of course, when we're going to see that the potential difference between the terminals of this specific source when no current flows to an external circuit is of course going to be the main source of electromotive force. Now whenever this particular circuit, perhaps if I can introduce another section which constitutes what we refer to as a switch. So maybe I can just give it somewhere. Let's have this one as a switch. So whenever this specific switch is closed, there's going to be current that is going to flow naturally from the source. And of course, there's going to be an internal drop in the voltage in this specific circuit. And of course, we're going to see that there's going to be an aspect of internal resistance of the battery, whereby we're going to see that this is going to be realized due to this specific aspect of internal resistance. Now I've mentioned of specifically some aspects whereby I've said that this specific source of electromotive force is going to constitute of a potential, of course, which we are going to refer to as the voltage in this specific case. Now this voltage has been given in terms of V. Now the circuit is also going to constitute of a flow of current due to the closure of this, or the closing of this specific switch. And therefore we're also going to see that apart from that one, we're going to have an aspect of resistance due to the presence of this specific component which I've given in terms of a resistor. And thereafter I've mentioned that basically due to the connection of this specific switch, there's going to be an internal drop in voltage where we're going to see that there's going to be an aspect of a resistance which is going to be offered by this source of electromotive force, and that is going to be the internal resistance of the battery. And therefore we're going to indicate that one as another form of resistance, which we are going to refer to as internal resistance of particularly the battery, which is going to be used in this specific circuit or the source of electromotive force. And we can therefore develop a relationship between the voltage, which particularly is going to be voltage of this electromotive force, and of course which is going to be the terminal voltage. And of course we're also going to look at what we refer to as this specific actual voltage which I've mentioned. Now in this particular case, we can develop a relationship where we are going to have the actual voltage given in terms of V equivalent to what we refer to as this electromotive force minus I R. Now, in this case, I've given this specific component. Now, in this case, we're going to have this electromotive force perhaps given in terms of this one. So we're going to have this one. Let me just give it in terms of this. So we're going to have this electromotive force given in terms of this specific symbol. Now, for us to find the actual voltage after the switch has been closed, it's going to be given using this specific relationship with which I've given in on the board. Now, this basically is going to refer to as actual voltage after taking care of that internal resistance, which is going to be realized due to the resistance of this specific battery, which we have given in terms of the PD source. Now, suppose we are going to have a question set, which is going to assist us in trying to evaluate this specific set which I had promised. Now, suppose we have, or we are required to use a well-labeled diagram to explain the internal resistance of our cell and how it can be measured. We're going to use this specific example whereby I've said that we can find the electromotive, of course, or this specific, of course, E equivalent to the sum of V plus IR. Now, assume that we understand what basically those specific initials stand for. And then we are going to have the second relationship given in terms of this specific equation. Now, we can expand this one in terms of including the current. Now, from Ohm's law, we are going to have a particular relationship which I'm just basically going to put this one here so that we can have this one. So V equivalent to IR, which basically is going to be the relationship from resistance equivalent to V over I given in this specific case. So I'm going to use this particular relationship for doing a substitution for this, whereby we're going to have this one given in terms of this one. So basically, let me use this symbol for clarity. So we're going to have that one given in terms of IR plus IR. So in this case, the current that we're talking about is the current which is going to flow in this circuit, and this is going to be the same amount. So in this case, implying that we are going to have this specific, of course, E equivalent to current into R plus R. And this is going to constitute the sum of the resistance given due to the presence of this specific component. And this is going to be the internal resistance due to the resistance from the battery given as such. Now, suppose we have this specific circuit whereby a 6 ohm resistor is connected to the terminals of a battery whose electromotive force is 12 volts and the internal resistance is 0.25 ohms. Now, we can do this specific evaluation using a particular example. We have said that suppose we have a circuit whereby a resistor over 60 ohms. So we're going to have this one given in terms of resistance over 60 ohms is connected to a terminal of a battery whose electromotive force is 12.0 volts and whose internal resistance is 0.25 ohms. So we're going to have R given 0.25 ohms given as such. So from this specific relationship, we can evaluate several aspects of this particular circuit, whereby if we are required to find the current in the circuit, so suppose we are required to find the current in the circuit, then therefore we're going to use this specific equation and make current the subject of our formula, whereby we're going to have current given in terms of A divided by R plus R given as such. And this is going to, of course, give us a particular evaluation we're going to use, which is basically equivalent to, so I'm going to do this one because of a space. So this is going to be 12 volts divided by 60 ohms plus 0.25. And this is going to give us, of course, a value in terms of course, amperes, which is equivalent to, so this one I'm going to get, so I'm finding 0.199 amperes. So for the first evaluation, whereby we are required to find the current flowing in this specific circuit with a resistor over 60 ohms and 12 volts for this EMF or a source of electromotive force, having an internal resistance of 0.025. We are going to evaluate current in terms of I from this specific relationship, whereby this is going to be the ratio between this E and of course R plus small r, giving that summation of a current. So suppose we are required to find the voltage or the terminal voltage of the battery, whereby the terminal voltage. Now we can evaluate for the terminal voltage of this specific battery by also using this equation 1, whereby we are going to have V equivalent to E minus IR. So implying that we can have V given in terms of, we can have this one given in terms of, so E is equivalent to 12. This is going to be the 12.0 volts minus the current is 0.199 times 0.25 amperes. So we are finding this one in terms of the terminal voltage. So in this case, the voltage is going to be 11.95. So I'm finding 11.95 in terms of the terminal voltage of this specific circuit. So kindly do, in case we find a difference in this specific evaluation, you can notify us in the comment section so that we can do a rectification, or perhaps if you find the similar figure, then it's going to be correct that way. Now suppose we are required to find the power dissipated, of course, in the resistor R. So the power dissipated in the resistor R, we can find power using the product of the summation of a current and of course, so I'm going to put this one as power dissipated in the resistor R. So later on we can find the power dissipated in the this is specific of course source of electromotive force. So this is going to be given in terms of just going to do this one because of our space. We do a substitution for the current, which is 0.199, the square of this one times 60 ohms, and then this is going to give us power in terms of watts, and this is basically going to give me the amount of 2.376 watts given as such. So this is going to be the power dissipated in the resistor given as R. And lastly, we can find the power dissipated in the other resistor using this same procedure. Small r given as such, and that is 0. Request our members to kindly check our description boxes for various links of other videos, and of course we are going to use the same strategy in trying to solve other problem sets which we are going to come across in our various discussions in our subsequent videos. So that is it for now, guys. Bye, God bless you. Catch us in our next video.